In this program, I would like to implement the algorithm of locating the point coordinates in one of the four quadrants. So let's develop that. So program begins with the name. So search. Okay. So we know the context for the time being. It is to search the end program search. Mm, okay. So let's write a bit of documentation. The search program is to get a point, point's coordinates, and locate and generate and print a message uh, regarding its coordinate. Okay. So let's save this program in the directory so that we can see the colors in the commands. So it should be saved in the working directory where the bin folder is located. So Fortran freeform file, and I write here the program name search.for. Search.for. It has been created in the directory, and we got the coloring of the commands program. Okay. So we will declare the variables, and to control that one explicitly, implicit none. So we will declare our variables by ourselves. So there are going to be real x and y, and I define a character variable that can only read one character, like y for yes and something else for no. So I would say character option, right? Okay. So let's write a message, print, enter, the point coordinates x, y. Okay. So then we will read from the default option. If the values are separated by comma or space, they will be considered distinct values. So after reading, we will like to add an if statement. Okay. If x is equal to 0, right? And y is equal to 0. So like I developed in the algorithm. So I'm here, if x is 0 and y is 0, so it is the origin point. So here I would write then the point is at origin, right? Okay. Then the other thing is else, when they are not equal to 0. So for else, there are going to be further possibilities. I would write another if statement. If now, if they are not equal to 0, and now I write if y is greater than 0, right? Then I print a message. Point is either in first quadrant uh, is either in first or second quadrant, or second quadrant. or second quadrant. So we are writing in the right. And then we can have another if statement. If now x is greater than 0, then now we are confirmed point print status point lies in the first quadrant. Okay. And there is the other option is directly is print asterisk point lies in the second quadrant. Okay. So this is the end of this if structure, right? And now for the if structure, so we add some spaces to improve the readability, that this is the end of this if structure. And now we have to write for this if structure. So then this is else if y is less than 0. So we have to consider further possibilities. So I will align this if structure with this one, right? So this is the outer if structure, and this is the one is the nested one, right? So if within if statement, this is the nested like structure. Okay. Else, since y is less than 0, so we have the other component. So like from our algorithm, so if y is less than 0, we have to write for this branch, right? So everything over here, this is to explore the possibilities when y is greater than 0. This was about these branches, right? It was about this branch and the further decomposition. And then now we are going to see for this if structure, the bigger one. So with the possibility when y is less than 0, so the point is either in third or fourth quadrant. And then we explore the possibility if x is greater than 0, then we can say print the point is in fourth the fourth quadrant, and otherwise else print the point is in the third quadrant. Okay. So this is the end of this if structure, right? Okay. So, but now we have to complete this one. If x is equal to 0, then and else. So this if structure, which should be aligned with the first one, it requires an end over here, and if, right? So this must be aligned with this these words. So if else, and there is the end if for the same one, right? So that is the nested structure. Now the option. Do you like to continue for the another calculation? So I'm going to print a message for the user. So this is the implementation up to, well, up to this part, right? And now for the new one, I write, do you like to continue with a new number, right? And then I write another message, print For yes, write y, right? And now we are going to read this y or something else, right? So now I'm going to read the option. I started with character opt. I will read a character, right? Character variable. It's going to read something which is meant to be a text one. So I read the option, and now I write for this character variable. If option is equal to y, then repeat the whole process, and this can be controlled with the go to statement in Fortran, right? So if yes, right? So I will repeat the step from the reading. So I suggest a label where I was reading the point coordinates. So over here, I provide a title, go to 100. So 100 stable statement label is over there, go to 100. And if this is not the one which is desired, then the program we write a message. Okay, you are done. And finally, the end program statement. Okay, where is the end? So this is required to demonstrate computer your logic. Oh, very nice. But the experiment is going to be the ultimate test of our activity. Okay. So this program has been saved. I can read the directory. This program has been saved in D directory where we have a folder subjects, then the scientific computing, then G77, then bill folder, and then there is the search.form. So I have opened that one earlier. So if I see the programs, so I have the recent file search.for. It is in the folder. So to access that one, I press here the cursor and write CMD. It will direct my system to access this folder. So with the uh, this system interface, so D subject scientific computing G77 bin folder. If I like to see the contents of the directory, so this is the same thing that we are seeing from the graphical interface. So we have search.for, and the same is available in the folder. Now it's time to compile CLS to clear the screen, and I compile with the command G77 search.for program name and -o to generate the object file in Windows system, and also this is the same one to generate in the Linux system. So then the name for executable file search.exe. Okay. Oh, so in line 12 there is a problem. Invalid form of if statement. Okay. The combined statement must be used with the parenthesis. So it is one statement. So now this will be considered as a combined or compound if statement. Okay, so this error was valid. So, okay, then print, uh, enter the point coordinates x, x, y, print else. Okay, I will ask again the compiler. Again, compilation command. Okay. Y command, oh, was the error? Maximize that one. Okay. Then continue. Okay. Let me please. Okay. Search.exe. If x is equal, so there is no problem. End of source file before the block ended. Okay. We have to carefully see this one. Okay. This is complete. Okay. Yes. Okay. So because y needs to be compared with the real number, x and y are decided to be real numbers. Okay. This is logical. Okay, good. Oh, again. So program search. So we are in a trouble. Let's try to get message from this one. Statement 2 is invalid if x is equal and y is equal. Okay. Mhm. Okay. Okay. I'm going to write here the word like if x is less than or equal to a very small number. The comparison of equality are troublesome if you when you are dealing with the real numbers. So I'm going to put here uh, this thing. If absolute of x is less or equal to 1 e raised to the power minus 6. So I will consider it like 0. And similarly, absolute of y is less than or equal to 1, oh, sorry, 1 e raised to the power minus 6. So let's see whether the program allows us to move ahead. Oh, so I'm in real trouble. That's why I say these experiments are the most dangerous experiments in the history of mankind. Oh, the program. Okay, end of source file before end of log statement. Okay, let's develop. Let's write the. Uh, let's eliminate the possibility of errors. I set this segment silent. Okay, just simplifying this one. Okay, okay. So everything is silent. If x is less or equal to 10 raised power minus 6 and absolute of y is less than or equal to 10 raised power minus 6, then point is at origin. Else, oh, there is a strange else. Else, I said this silent. Okay, so this should be considered and then this one and else there will be the end if. Okay, so print asterisk point is not at origin, right? So it is at origin or it is not at origin. So we have simplified only two conditions. Okay. It means these if statements are written correctly. Now let's run it and see the output. Okay, enter the point coordinates. I set 1 and 1. So point is not at origin. Do you like to continue with a new number? So yes for y. Enter the point coordinates. So if I say 0 and minus 1 exponent minus 3. Yes, the point is not at origin. 10 to the power minus 3 is considered. If you want to continue, y, and then enter the coordinates. So 0 and 0. So point is at origin. Do you like to continue? We don't want to continue. So you are done, right? So it means the outer loops, they are correct. So now for other checks, now let's open up our commands. Okay, if is greater than 0, then print. Okay, this is allowed. This is allowed, print that one. Okay, so if this is greater than 0, then and okay, it allows over here point is either in first or second quadrant. Then there is another if statement. If x is greater than 0, then okay, allow then okay, this one, else. So this is with the this is the end if for this one, and if y is greater than 0, I must have an else. Okay, okay, else point is either over here. If it is greater than 0, okay, and then else, okay, and this is the end if. So end if, okay, well, I and if, sorry, there, this is the end if. Oh yes, that was the error. So we must have the end if for the y statement. Okay, so that was the error, and if. Okay, point is not at origin, and then end if. This is end if. Oh no, this end if is written point is not at origin, and then there is the end if for that the point is not at origin. So else, okay. Well, this there is end if required. End if is required. That's why we write in the structured programming, right? Okay. So if there is the end if for this, else there is the end if, and there is the end if for the for eliminating the possibility of having the point at origin. So this is the edit, right, after the first algorithm, right? So this was the option that we need to thoroughly investigate. So this is a great time and great memory that we have explored the possibility in a very systematic way, right? So that will definitely build the character. So now we are ready to see the working of this algorithm. I hope this will not refuse me. Yes, yes. Uh, Programming works, and I'm still alive. So excited to see the complete thing on the line of fire. So enter the point coordinates. I would like to see a point 1, 1. Okay, the point is either in the first or second quadrant. Point lies in the first quadrant. Point is not at origin. Do you like to continue for the next number? Yes, very happily, like excitingly, swinging on the pendulum like Professor Walter Leuven, or even more excited. Point y coordinates. So -1 and minus 1 and 4. So I'm looking for the where this point is going to lie. Is going to be in the fourth quadrant. So next part of the loop, x is -1 and y is positive. It is second quadrant. Okay, point is in first or second quadrant. Point lies in the second quadrant. not at origin. Do you like to continue? So no one can laugh now because I'm prevailing with my program. So the new point, -3, -4, looking for the possibility in the next loop. -3, -4, third quadrant. Point is either in third or fourth quadrant. Point lies in the third quadrant. Yes. Okay. Now for the last possibility with the fourth quadrant, I have to set x positive and y negative. So in the fourth quadrant, so all possibilities have been explained and explored in this program. So it means we have done. So let's see. Do not proceed. Stop here. You are done. You are done. So after this demonstration, I will take a deep breath. It will definitely calm my mind.